Find the surface area of each of the prisms below. So if we look at the first one, we've got a triangular prism and the end is a right-angled triangle. Now I've got an X here to remind us that we're going to need the length of that slope. So let's have a quick look at that triangle. So it's 8 centimeters this way, 6 centimeters that way, and this is X. So Pythagoras' theorem gives me X squared is 6 squared plus 8 squared. That's 36 and 64, which is 100. And so that gives me that X is equal to 10 centimeters. So I can now start identifying my surfaces. So the end here is a triangle, and the one on the back there will also be the same triangle. And that is, of course, this triangle just here. So if we think about the triangular end, so 8 centimeters, 6 centimeters, there's 2 of those, one at each end, and we've got 8 times 6 and divided by 2, so that is 24 square centimeters, and that would be a bad thing to do. 24 times 2 gives me 48 square centimeters for the 2 triangles. Then I've got 3 different rectangles. If we look at the rectangle at the back of the shape, that one is 6 by 6. So the rectangle at the back is 6 centimeters by 6 centimeters. We only have one of those. It is 36 square centimeters. If we look at the one on the bottom, that rectangle there is 8 in this direction, and then it's 6 that way. So we've got 8 times 6 is 48 square centimeters. And then you've got the one on the top. Now we worked out that the length X was 10, and of course the width of that rectangle is 6. So we've got 10 times 6, which is 60 square centimeters. And so my surface area is going to be the 48 for the 2 triangles, add 36 for the rectangle at the back, add 48 for the rectangle on the bottom, add 60 for the rectangle that's sloping, this rectangle down here. And we just need to add those up. So we've got 48, add 36, add 48, add 60, gives me 192 square centimeters. I'm just going to introduce a quick shortcut for working out the 3 rectangles. If you look at the triangle at the end here, the perimeter of that is going to be 8 plus 6 plus 10. So that would be 24. If I do, so this is the alternative, if I do that perimeter, multiply it by the width of the shape, which we know was 6, and that is, of course, this 6 up here, and then add in the 2 triangles. The 2 triangles came to 48. So this is the 2 triangles. And this one here is the perimeter times the width. And you'll see that we get the same answer. Now, you don't have to use this. You don't have to use that method, but it can save a little bit of time. Now, if we think about the cylinder, always refer to a question to see if it does have a top and a bottom, but we're assuming here that this is a solid shape. So we've got two of these, and the radius is 12 millimeters. So we're going to have pi times 12 squared, which will be approximately pi times 12 squared, 452.39. Let's just put 38 dot dot dot. And obviously we have two of those. And so for top and bottom we get 904.77 and so on. I haven't bothered with any rounding yet, you notice. Then we've got the curved surface. Now in the intro we said that that curved surface would unroll to a rectangle. The 25 here becomes the height of that rectangle. When you unroll it, it's the circumference that becomes the top. So the top is 2 times pi times the radius. Remember, the circumference of a circle is 2 pi r. Down here we use the area is pi r squared. The overall surface area is going to be the curved surface, add the two rectangles. So my surface area is going to be my 904.77 and so on, added to 2 times pi times 12, which is the length here, times the width, which is 25. And then we can calculate that. So I'm leaving that answer in, and I'm just going to say plus 2 times pi times 12 times 25, which is 2789.73 and so on. And we'll say that that is equal to 2790, and that would be in square millimeters to the nearest integer.